Excellent. All right. So welcome everyone. Good day, good morning, good evening, wherever you are. Welcome to the week 2 session of the CLC1 Supply Chain for Health course. Unfortunately, today Gilles is not available. He has been called for an unscheduled meeting by one of our donor partners. So unfortunately, he had to go. Um, I would request everyone to make sure that your mics are muted when you're not speaking. If you wish to speak, you can either unmute your mic and speak, or you can also raise your hand, and then we will, as soon as we finish a chain of thought wherever we are, and then we will let you speak as well. So today, this is the second week of the course, and I congratulate everyone, who has been religiously following the calendar and doing the course, and we will also see who's where. We like to be transparent in this entire endeavor because our course is like a community based online course where everyone must know where everyone is, everyone must know what the other person is doing. So we don't like to hide anything. Sometimes some people don't like to share if they are behind. But it may also encourage you. When you see your peers going ahead in the course and you are lagging behind. So just don't take it negatively when we show the progress. If someone is lagging behind, that means that you really need to pick up the pace. There are no judgments there. Um, so today, before we begin, I would just like to share some screenshots of the week 1 assignment. So, like we had discussed in the previous session, in the week 1 assignment, you were required to sketch first of all the overall supply chain of your country, and then show 3 flows which we discussed in the last session: flow of products, flow of money, and flow of information. So we will take just a few minutes, and then I'll invite if someone is. I don't see Nosiba here. I also don't see Genet here. So otherwise, I would have asked them to explain their sketches. So Nosiba is from Sudan. She has sketched the health supply chain of Sudan. Let me also. Okay, no, I can't do that. So if you see here, one of the key stakeholders in the center is the Federal Ministry of Health in Sudan, under which there is a National Medical Supplies Fund, which is the supply chain organization of Sudan, and everything related to medical supply chain in Sudan, it happens through NMSF, and it's a centralized federal structure in Sudan. So NMSF procures everything from outside. Majority of it, there are some local manufacturers in Sudan as well, but majority of it is procured by NMSF from outside. NMSF has 16 branches. So, once they procure, they store at the central warehouse, which you see in the graph, central level. From there, it goes to their branches. And then from the branches, it goes to the hospitals and the facilities and any other place where the products are required. So this is the chart of Sudan. Although in this chart, Nosiba has not mentioned, maybe I can't see it probably. How does the uh, money flow, and also how does the information flow in Sudan? So I urge everyone, whoever has try to do this, also try to understand where is the information getting originated from, what is the source, and to what level it
Why?
is going.
I
And
didn't title
also,
the report.
Aromi, can you mute yourself? Thank you and welcome. It's good that you're here. Also try to look at the flow of money, because it's very important. If there are no funds, it will be very difficult for any procurement agency to purchase those products and then redistribute wherever it is required. So, for example, in the case of Sudan, what I can tell you is that they follow a revolving drug fund. So the patients, they pay for the products, and each facility through the branches of NMSF, uh, all the money which is pooled, it goes to the revolving drug fund, which then is accumulated at the central level of NMSF, who then again uses that funds to procure the medicines. Although in Sudan, the federal government sometime as well, they help the NMSF by allocating some funds to them as well to purchase the products. But the majority of products for the supply chain of health comes from the revolving drug fund. On the other side, you see Ethiopia, drawn by Genet Elemu. It looks slightly complicated, because there are a lot of hospitals, health centers, Vareda Health Office, health posts. She has drawn everything, and then at the center you see EPSA, Ethiopian Pharmaceutical Supply Agency, which is the central stakeholder under the Federal Ministry of Health. Again, in Ethiopia, predominantly it's a centralized structure. However, for the health facilities and hospitals, public health facilities and hospitals in Ethiopia, it is not mandatory to purchase from IPSA. Majority of it they do purchase it from IPSA, but it is not mandatory for them to purchase it from IPSA. They can also purchase it from the private sector, from the wholesalers and importers. They can directly purchase it from there. So the IPSA supply chain, which is, let's say, 80% of it in the country, it follows this structure where the product is sourced from outside. It comes at the IPSA central warehouse. From there, it goes to the hubs warehouse. They have 17 hubs, if I'm not wrong. And then from the hubs, based on the demand of the various facilities and hospitals, it is then transported there. In between, there are some coordinating agencies in Ethiopia. So, for example, each region has something called a regional health bureau. They coordinate everything about the health services and health products within their region. And then in each region, there are several voredas. So voredas are like units within a district. You can say units within a big region. So you can, in some cases, you can say that a voreda is equal to a district, and in some cases, you can say voreda is a sub district. So at each voreda level, there is also a health office, and they also coordinate the supply chain of products within their own voredas, and they coordinate with the all the health clinics within the voreda, and then they also coordinate with the IPSA hub, which is located in that region or in that area. So that's how it flows. In here, the bold lines are flow of products. The dotted lines are information, and I think it was also color coded. It's not very clearly visible, but there is also a flow of money as well. Again, in Ethiopia, it's a revolving drug fund. It's the same structure like Sudan. Patients pay for it, and then it's accumulated at a central level, and IPSA then uses that money to purchase the products once again, and then redistribute it to the hubs and so on and so forth. In the supply chain. So these two countries are very similar. On the next slide, I have the supply chain from Cameroon, and I think Matthias is here today with us. So Matthias, can you explain everyone what you have drawn? It looks very complicated to the eye, but I'm sure you can explain it to us very quickly in a few simple words. So please, if you can explain it to us, that would be great. Over to you. Matthias, can you hear me? Okay.
Yes, I can get you.
Yeah.
Yeah, it looks a little bit complicated, but what I'm just trying to
Matthias, we've lost you. Matthias, can you hear us? Mm. Matthias, whenever you are back, do let me know. I'll come back to this slide again. It would be good for everyone to understand how the supply chain is in Cameroon and how the various flows they work in Cameroon. Also, not to say that we have people from other countries. Some of you have tried to sketch sketch the supply chain as well. Uh, so I've just put down some uh, nice looking, I would say, graphs here. But yes, there was one from Nigeria. There was another from um, I just forgetting the name of the country, but there was another one. But I really insist that you also look at these flows which has been drawn by Nosiba, Genet, and Matthias, and try to rethink on what you have done. Whether you have done it in the right way, whether you understood the assignment. Maybe some of you did not have much time to do that. But I tell you, this is a very important exercise, and it sets the tone for the entire next 3 weeks. Because if you look at this flow, then you can also map out which supply chain function is happening at what level. Because in the assignment it also asks you to map that. Maybe you have not looked at. I mean, here Gwyneth has written it that at IPSA Central, product selection happens, procurement happens, contracts happen, and warehousing and distribution happen. So here at regions as well, warehousing happens. So Gwyneth, welcome. You are here. I was just explaining the chart that you have drawn it pretty well. I've already explained it to everyone since you were not there. But it's very good. It's very well labeled. So, for example, here in the health center, she's written that the medicines are stored and dispensed as well. So she's also written the um, supply chain functions along with the levels as well. So it's very important that you rethink about the supply chain structures in your own country, and try to determine at what level, what are the different supply chain functions happening at each level. And for a country like Nigeria, for example, uh, each level, because you have different levels. Like I was reading in one of the discussions, Madam Okafor, you wrote that it's a very mixed structure. There are several stakeholders, different levels, from a federal level to a state level to a local government level, and you will see when you try to map it out like this that several supply chain functions, or rather similar ones, are happening at each level. So forecasting is happening at a federal level as well, at a state level as well, and probably at a local government level as well. And same with procurement as well. Some products in Nigeria are procured at a federal level, some products are procured at a state level, and then some products are procured at an LGA level, local government level. So the same supply chain functions are happening at different level. And it may be true for other countries as well. When you try to really think about it, that where is it happening and how. Okay. So it's very important again to draw this comprehensively, because it will set the tone for the next few weeks. Because the entire course will follow this structure in terms of stakeholders, in terms of supply chain functions, in terms of what is happening where, the complexities. And if you see in the chart of Gannett, although she's made it a bit complex to the eye, although in Ethiopia it is not that complex, I would say. Having worked there, I can say it is not that complex, although there are several stakeholders as well. And same, I would really like to see the structure in Zimbabwe, where Charlotte is. Maybe Ihab, I didn't see your assignment. You can also tell us how it is happening in Iraq. Maybe Noor Abdullahi can share with us what's happening in Somalia, and so on and so forth. I would really like to see what's happening in other countries. And in a comprehensive in a comprehensive way, not like five boxes and then just four lines and five boxes. Please try to make it a bit more comprehensive. If you look at the
Hello.
yes, Noor.
Yes, maybe I've not seen this assignment, but can I share after it, after 14th of this month?
Yeah, that's okay, that's perfectly fine.
Yeah, okay, thank you.
Yeah, okay. So, if you see some of the examples which we have showed you on the assignment page, you would see how comprehensive they are. I mean, I really like one of the images from Madagascar. Madagascar is very complicated. There are several stakeholders who are doing the same things at their own levels. And there was someone from Madagascar who drew it really, really well. So take some cues from there. There are some images over there. Similarly, DRC, Democratic Republic of Congo, is very complicated, but there are some people who have been able to draw it very nice. So try to do that, and then you will also see that you may uncover something new while doing that, which you did not know before. So quickly moving on, since Matthias's connection is not that great, Matthias, maybe you can send us a small write-up. Maybe you can put it on the group on Hive, so that everyone can also read uh, what is it that you have drawn. So what we're going to do is we're going to post this image on the Hive on the group, and then we'll tag you. So once you receive that notification that this image has been posted, please go there and write the entire story behind this image, so that everyone can also read and understand what is happening in Cameroon. Okay, that would be really appreciated if you do that. So moving on, this is here the participants' progress that I was talking about before. So on the green line, if you see the ideal progress somewhere until the mid of module 4, majority of you're doing very well. I would request Arome, Folita, Noor Abdullahi, Huber, Premise, uh, whoever is here, to please pick up the pace. And then Ahano and Samayog. Samayog, I haven't seen him yet. So maybe Priyanka, try to see where he is, try to reach out to him. But Ahano is here. Ahano, please, you will be lagging behind eventually. And some of these classroom sessions will not make full sense to you. Please, we request you to log into the platform and go through the modules like all the other participants and participate in the discussion. There are some very interesting conversations happening on the discussions. I've been reading all of them. I've been asking more questions on top. Some of the participants are also responding to those questions. So I will keep on reading whatever you write, and wherever I feel that there's an opportunity for more questions, for more insights, I will tag everyone. So if you see your name tagged, please go back to the Hive. Please look at the question and please try to respond to those questions, because it will help everyone understand these concepts, and eventually will also help you gain more insights about those topics. Okay. So this is the participant progress, which we looked at about 4 hours before this session. If you have improved your progress since then excellent. If not, please follow the calendar. Next In the next session, we will show you what's happening in the week. Okay, Noor is saying he's stuck in module 2. Okay, so Noor, it's okay. Priyanka will help you after this session. Priyanka, please note Noor is stuck in module 2. If you
Okay.
have any problems, please reach out to Priyanka either on WhatsApp, on email, wherever that you think, or you can also send an email to the info email ID. So you have Priyanka's email ID, you have the info email ID. Please send us any issues and we will resolve it as soon as possible. Okay. So moving on. So this week, week 2, there are 2 modules that you need to complete. In addition to, please, can you explain the bars to us? Oh, okay. So the bars is, So in total in the course, there are about 62 steps, if I'm not wrong, 62 or 65 steps, excluding the quizzes. So on the bottom are all the steps until module 4, which is about 41 or 42. So since we are in the mid of week 2, so the ideal bar of green is at about 39, because by this time you should have at least done the forecasting techniques, the lesson under module 4, because this is what this class is about. So if you see Genet, Lamin, Matthias, Seth, and yourself, Madam Okafor, you are almost there. Maybe you have not uh, gone on to do that lesson, particular lesson of module 4, but you are still very much in line to complete module 4 by end of this week, and then move on to module 5 for the next week. Similarly, other participants, they are in module 3 or module 2, and some are on module 1 or maybe beginning of module 2. And then, some people have not started yet for some or other reason, which is what I'm saying, trying to encourage them that, to start the course. So this is what these bars mean. They're the progress until today, more or less. Okay, so moving on, like I was saying, two modules this week, products in public health supply chain, which is also talking about product selection. How do you select which products to select for your supply chain? And then once you select them, how to plan for the demand. There are some discussions. There's an interesting discussion about RACI. I've heard some people who are talking about they have been using RACI in some other places, but not for quantification. The reason why uh, we talk about race in quantification is because in majority of countries, quantification is done in a very collaborative manner between different regions, the federal structure, some technical partners, like for example, JSI, Chemonics, PATH, WHO, UNICEF, UNFPA. So all these organizations would be supporting you, and for different programs sometimes, or for essential medicines as well. And plus, there may be some donors as well. They may also be involved. So how do you make sure that all these organizations and all the stakeholders within the government and outside the government, they know what to do, and how are you communicating everything along this stakeholders matrix. So this is where a simple tool like RACI comes in handy, where you constitute a committee and give very exclusive responsibilities and accountabilities to stakeholders on what they are supposed to do. So on one side, you write all the activities which are needed for the objective that you are focusing on, and then you write the name of the person and the organization, whoever is responsible, accountable, consulted, or informed. uh, Many people, they get confused between the two points of being responsible and accountable, which we learned in the previous session, that accountability means who in the end is the sponsor, let's say, for that activity. Who will be let's say, who is accountable for the public, let's say, for the citizens of the country in that sense as well. And the responsible person is the one who's doing it. you know Responsible and accountable can be the same person. Sometimes, in some cases, someone who's accountable is also the same person who's actually doing the task. But in most cases, and also for ethics and compliance and structures, we try to make sure that the accountable person is someone else, and the person who's actually doing that job is someone else. So make sure you understand a distinction between who is responsible and who is accountable. Then finally, there's an assignment under week 2 as well. This one is linked to today's session, where you will be given an Excel sheet. uh, there will be a case in the Excel sheet, some numbers in the Excel sheet. You have to use a formula And once you do all that, you go back to the platform, you get some questions, and you answer those questions based on what you have calculated, in that Excel sheet. So please pay attention to today's session, because the same you will have to use for this week's assignment. So in today's session, we'll discuss some basic methods to undertake forecasting, and then we'll also understand how to ensure accuracy of forecasts in the long run. Okay. The house rules stay the same, which I have discussed before. If you have any issues, you can also write on chat. You can also raise your hand, but make sure your mic is muted if you're not speaking. So we'll begin this session with a quick poll. So Priyanka, can you launch this poll? I mean, in my own experience, wherever I've traveled, I've heard that people find forecasting very difficult. Uh, Now I don't know why. It may be because of calculations. It may be because of coordination that it requires, or it may be because that data is very difficult to collect. And if you don't have excuse me, and if you don't have the right data, it really becomes difficult to do accurate forecasting. So a lot of stakeholders that I've worked with, a lot of people that I've worked with, they struggle a lot in forecasting. And I also want to ask you as well, that do you find forecasting easy or difficult, at a personal level? So please, if you can quickly answer this, then we'll move ahead.
Not a lot of people are participating in the poll, so I would request everyone to attempt it quickly.
Wow, excellent. Now, I don't know the number, how many people have participated, but 60% is saying they find it quite easy. So then today's session should be a cakewalk for you. Um, I will ask one by one, I'll ask everyone to take the scenarios that we're going to present. But yeah, there are some people who are saying that they have never developed forecasts. Okay. So it is good to understand that you don't find it find it difficult. Uh, but yeah, the forecasting it means that there will be some numbers, there will be some calculations to understand what is required. So quickly moving on, if you have gone through, if you have started module 4, then you must have seen this chart in the lessons where we're talking about the overall quantification process. So quantification is a broad term, and the outcome of the quantification is a detailed supply plan, which you hand it over to the procurement team. Based on this supply plan, the procurement team will, purchase uh, the products in the timeline that you have mentioned. You know, however, to reach that supply plan stage, you have to uh, in a stepwise manner do a lot of things. First of all, you have to define how you are going to do the quantification for which program, where the data is coming from, what kind of quality of data is it there, and then eventually have to collect the data as well. Once you collect the relevant data, Matthias, can you mute yourself?
This is how we do it. Hey, Mati, big boy.
Matthias, can you mute yourself? Thank you. Yeah, thank you. Yeah. So once you've collected all the data, you need to also define how you're going to do the forecast, how you're going to develop the forecast. That is step number 2. So today we're going to focus on this step number 2. Once you have developed your forecasts, then you look at how much existing stock is there in the country or at various levels wherever you're doing this, how much stock is in the pipeline, what kind of wastages that you're looking at, what kind of expiries historically that you find in your system. Then you adjust your forecast based on those data. and then you prepare your supply plan as to when those products are needed in the facilities, in the regional hubs, or in the hospitals, wherever, for whichever system that you are preparing your supply plans. So that is step number 3, after which you hand it over to the procurement team. But today we are going to focus on the step number 2, which is just forecasting. So today we're not talking about anything about stock on hand. We're not talking about stock in pipeline. We're not talking about wastages and expiries. We're only talking about forecast techniques, because there are several ways of preparing a forecast. Okay. So step number 2, this is what we're looking at. So forecasting refers to predicting future events, and forecasting is a very universal thing. I mean, everywhere we do forecasting. For example, weather forecasting, so your weather department, they look at the data, they collect the data, and they forecast whether it is going to rain or not, whether it is going to be hot, when and how, so it's there in forecasting. Sorry, forecasting happens in sports, forecasting happens in politics. Political parties, they will forecast how many legislative assembly seats they're going to win in that election. So they do the forecasting, they use their own data. So it refers to predicting future events which has not happened by carefully analyzing relevant strategies and plans, underlying assumptions, and the environment. So we need to understand that it is only not about historical data. It's also about some assumptions. It's also about the overall environment that you are in, and your relevant strategies and plans based on which you want to undertake a program. Specifically in health supply chains, it means to predict how much product quantity will be required to satisfy the health needs of the population at a future time point. So if today we are starting a forecasting exercise, we are doing it for probably next year, or maybe the next 6 months. We're not doing it for today. We're doing it, a point in time in future. Even at home, if something is going to run out, you don't try to look for the quantity which is needed once everything has run out. You try to do that before, so that by the time something runs out in your home, you have already made the purchase. You already have the next amount, or the next bottle, or the next pack to open at your house. So same thing here. So we do the forecasting well advanced in time, so that by the time our stocks run out, we have the new stocks come in. So that is the main point about forecasting. We do it in a way that we look at the future while we are doing the forecast. So before we move on with what kind of data, because the next slide is about what kind of data is used for forecasting, there's a quick quiz. This is not a poll, this is a quiz. And it's a multiple option quiz. You can select more than one option. So what we want to tell us, what we want you to tell us is, what data sets can you use to develop forecast? Can you use services data? Can you use surveillance data? Can you use consumption data, adverse events data, and household data? Which of these data sets can you use to develop forecasts? And the poll should be on your screen. Sorry, the quiz should be on your screen anytime now, Priyanka. And here it is. So you need to select more than one option. Try to select the right option out of these 5. And then we will see which are the correct ones on the next slide. Okay, excellent. So consumption data, everyone has selected. Services data, majority of you have selected. And then some of you have also selected surveillance and household data. Okay. Excellent. Whoever has selected consumption and services, you're absolutely right. But there is one more set of data that we can use for forecasting, and let's look at it here. So the most usual suspect is consumption data, and I think 90% of forecasting in health supply chains, it happens using consumption data, because of the main reason is that it is easier to collect, because in supply chain we are collecting consumption or issue data, so that's why majority of forecasts, they're developed using consumption data as well. Now, ideally, consumption data means actual dispensation. It does not mean it does not uh, mean the quantity of product which has been issued from a warehouse or a store to a facility. Consumption means actual number of dispensation from the facility to the patient. How much of the product has been dispensed to the patient is actually consumption. Okay. So if someone is using issue data as a proxy to consumption, I mean, yes, you can do that if consumption data is difficult to collect, but the error rates in using issue data as a proxy for consumption data is very high. Okay. Next in line is services data. So what is services data? Services data is the number of patients or consumers who visit a facility and get health services. Like, for example, 600 women were given oral contraceptives. So which means that 600 women visited health facilities, maybe more than once, because oral contraceptives, they need to use every month. So maybe they're dispensed, the contraceptives once every quarter, once every month, whatever the rule in wherever that you are. But it means number of patients. So if you're doing it for HIV, then how many HIV patients came to the health facility, or how many are registered with the health facility? If you're doing it for TB, how many patients are receiving the TB products, for example? If you are doing it for any other medicine, like anti-infectives, antibiotics, and antibiotics, antimicrobials, then you need to look at, number one, the number of patients who reported any infectious diseases, or the number of instances, number of prescriptions, for example, that has been issued for any kind of infectious disease. So that way also you can look at how many patients were there. In terms of vaccines, you can also look at how many children were given vaccines in the previous period, for example. You know, and then finally there is a morbidity data or surveillance data. Both are same. We do surveillance to find out what is the morbidity related to a disease. So this data is collected to understand the magnitude of certain disease or illness in a population. For example, annual incidence rate for malaria for any particular district is 5%, for example. So 5% means that even if in a district there are 100 people, then 5 people will definitely have malaria in 1 year. So this data, it is collected by the health authorities. They do sampling. They look at the data from the hospitals, from the health facilities, from the community itself, and they figure out these percentages of morbidity related to any disease. Okay, so this is the third kind of data, and it was also written in the poll as surveillance. So surveillance data or morbidity data is the same. So you do surveillance and you identify the data related to any disease, which is eventually called morbidity data. So these are the data sets that you use. So today's exercise, we will use all three data sets. Now, there is a catch of time. I really want to really want to do two scenarios which are linked to the weekly assignment. The scenario on morbidity is slightly complex. It is on malaria and it is slightly complex. So if time permits, then I will also show you that as well. I hope you all have the Excel sheets which Priyanka had sent this morning. If you have those, please open it up and we will look at it together. I will share it on my screen and you can also look at it on your own screens where you have the Excel, so that you can also follow the calculations and everything, the method. Okay. So we'll start with the basic idea of where this forecasting is happening. So it's a hypothetical scenario of something called a district X. It's a very mysterious district. That's why it's called district X. Um, it has a population of 200,000, and there's an annual population growth rate 3.2%. You might be asking, why do we need to understand a growth rate? We'll discuss that later. District X has 5 sub-districts. The source of the products is that they import everything. There are no local manufacturers. And the key supply chain stakeholder is National Supply Organization, which is under the Ministry of Health. So in scenario 1, we are going to create a forecast for ciprofloxacin 500 mg tablet, which comes in a 10 by 10 secondary pack, which means in the secondary pack, there are 100 tablets. It is used for typhoid, diarrhea, infections of lower respiratory tract in District X based on their standard treatment guidelines. It's under the program of essential medicines. In terms of program target, there are no new targets. So what it means that whatever cases of typhoid, diarrhea, infections, etc., will come, they need to be treated using ciprofloxacin. It is funded by Ministry of Health through the Drug Revolving Fund, and the forecast period is 12 months. I'll quickly take the question of Noor Abdullahi, who's asking a distinction between surveillance and morbidity. There is no distinction between surveillance and morbidity, Noor. Like I said, in different parts of the world, they use different term to write the same data. Now, the small distinction is that the process by which you collect the data is surveillance. So you may have heard that WHO, UNICEF, UNFPA, and even your local government, they do the surveillance, surveillance for diseases. So once you do the surveillance and you analyze the data which eventually comes is also called morbidity data, which means that what is the probability of people getting sick out of some disease, that is morbidity. Okay, having or getting sick, that is morbidity. So there is no distinction. It's just that different places, some people call it surveillance and some people call it morbidity, but it's the same set of data which tells us the probability of any sickness in population. Okay, so for example, in this example which I showed you before, annual incidence rate for malaria is 5%. So that is a morbidity data collected using surveillance techniques. Okay, I hope it is clear now. So this is the scenario for ciprofloxacin. The objective is to do the forecast or prepare the forecast of this product using average monthly consumption. So this is the method that we're using in this scenario, AMC, average monthly consumption. Now, before I show you this one, let me quickly do this poll and then go to the Excel sheet. So Priyanka, can you quickly launch this poll by the time, I share my screen, and then you can stop sharing your screen so that, everyone can see my screen. Okay, so let me increase. Okay, so 75% are saying that they have used AMC calculation, so that's excellent. Whoever has not used it, so please pay attention. This is a very simple exercise. So as you see the scenario, forecast using consumption data. So the same detail that I showed you on the slide is written here. Ciprofloxacin 10 by 10, indication under drug revolving fund, forecast period is 12 months. District X, growth rate of 3.2%. Now, we have some data here from January 2017 to December 2018, 24 months data. The forecast period is January 2019 to December 2019, 12 months. So we have the consumption data in number of tablets here. Okay. Now we know that the secondary pack is 10 by 10, that is 100 tablet in one pack. It is ideal always when we're doing forecasting to convert the data in packs, because this is how eventually the supplier will send you the material, right? So that's why we also do that. First of all, we convert the number of tablets into number of packs by dividing the number of tablets by 100. So this is the number of tablets in each pack. Okay. Once we calculate it for each month, then we do a sum. Okay. So sum, I hope everyone know how to do sum of the fields in Excel. So it says that in 2 years, 2,139 packs were dispensed or consumed of ciprofloxacin 500 mg tablet. So what is the average monthly consumption? So the formula for average monthly consumption is that we divide the sum of quantities consumed by the period. So it's slightly spelling is wrong. It's actually period. Okay. So we divide the sum of quantities, which is for us is 2139, as we saw here. This sum, which is 2139. We divide this by 24. 24 is the period from January 2017 to December 2018. It's 24 months. So if we divide 2139 by 24, we get average monthly consumption, which is 89 in this case. So if I just show you the formula, dividing 2139 by 24. Now, this is the AMC for that 24 months. Okay. But we are supposed to do the forecasting for the next year. Next year, there may be more people, right? There may be newborn babies, and because there's a population increase. So that's an assumption that we're going to make here, that in the next year, since there's an annual population growth, there may be 3.2% additional people who may get sick. So we add this 3.2% into our AMC. So AMC, which is K21, adding 3.2% into this AMC. So the adjusted AMC becomes 92 rather than 89, which is from the past 2 years. Since we are doing the forecast for the next 12 months period where the population may increase, we take an assumption with the proper documentation that we are assuming that there will be an increase in the number of patients in the next year because of population growth. You may also say that some people may die. That's true, but we don't know that data. The data that we have is that there is 3.2% growth rate. We don't know how many people are going to die. If we know, then we can also deduct that. For example, we may choose to not to deduct that because it may be good to have slightly extra amount because there may be some wastage in the end eventually. So that is up to the up to the team who's doing this forecasting. But in this case, we have the data that the growth rate is 3.2%. That is what we're going to add here with this formula. So the adjusted AMC becomes 92. And to do the forecast of 12 months, we multiply 92 with 12. So we come at 1104. Okay. So in the next 12 months, using the AMC calculation, district X will need 1,104 packs of ciprofloxacin 500 mg tablets. Okay, for 1 year. Okay. Now, let me, Priyanka, can we quickly go back to the slides? I'm just stopping my, I hope I want to just explain something about AMC. If you want, I can also share from my side. Priyanka? Yeah, okay. So if you go back, okay, let me do that. Yeah. So you may ask that, can we use AMC every time? Because it's a very simple way of calculating forecasts. So I will tell you, probably not always. Now, the best case scenario for using AMC calculation is when a forecasting is being done at a health facility where your situation is not very complex. You know the exact consumption uh, or historical consumption for a particular product. And mind you, consumption, not issue data. If you have issue data and you are doing AMC, it's a misnomer then. It says average monthly consumption. It doesn't say average monthly issue, right? So doing AMC calculations using issue data is a big mistake. You may get away with it eventually, but you will have a very high error rate in that forecast. Second point is calculating months of stock available at a health facility or a warehouse. Using this AMC calculation, you can also understand how many months that your stocks will last. Okay, so if you have a monthly consumption of 89, let's say for example, and in your stock you have 300 packs remaining, so you can safely say that your stocks will last for at least 3 months, if not more, so that in the 3 months you need to get a fresh supply of product. Also, AMC is most useful when consumption is mostly steady for the essential medicines like anti-infectives or products like anti-diabetic products and so on and so forth, where consumption is steady. It does not fluctuate too much. So AMCs are useful there. Also, one more point, in many guidebooks and manuals and policies or even trainings, you will see that people are calculating AMC by just using 3 months of data. I would advise to have at least, if not more, at least 12 months of data to calculate AMC. In 3 months, it is very short. I mean, yes, it is good to show that calculation just as an example, but in reality, please do not calculate AMC by just using 3 months of data. Because if you're doing it for a health facility or a smaller store, if you just use 3 months of data and you are just creating forecasts based on AMC, again, you will have a very high error rate, because 3 months do not represent what is going to happen for a particular disease in a full year. If even if I mean, although AMC calculations, they don't take into account uh, all the fluctuations, but at least if you take one full layer of data, at least it will average out some level of fluctuations and give you uh, let's say a rather correct estimate of what is the monthly consumption, instead of if you just take 3 months or even 4 months or 5 months. I would say minimum take 12 months. If you have 24 months, that is the best case scenario which we have shown you in the Excel. Okay, so have a rather large set of data if we are trying to use AMC. Okay, and this is our uh, you know analytical opinion. We have analyzed a lot of data, and we have figured it out that when you do it with just 3-4 months of data, it's rather inaccurate in most cases. So that's why this is the conclusion that we have drawn after supporting a lot of organizations in forecasting. So the next, before going to the next scenario, which is about services data, if there are any questions that you have about average monthly consumption, how to do it, the formulas, please you can ask. Priyanka, in the meantime, you can stop the screen. Oh, okay. actually don't stop the sharing because I need to show the scenario. Yeah. So if you have any questions, please do ask. So is anyone working in family planning programs? You can just raise your hand or you can also speak. So what is AMD? If you can expand, Seth, what is the D? Distribution, exactly. So Shailat is saying that she works in family planning. Okay. So this is what I was saying, Seth, that with issue data or distribution data, forecasts have a high possibility of error. Seth also works in family planning. I think that's why he's raising his hand. So I was saying with issue data, forecasts may be very wrong because issue data does not mean that the patient is going to need that product. You have issued it to the clinic or the health facility or the hospital, but it does not mean that the hospital or the health facility have used that product. So you can use it as a proxy if in a worst case scenario that you're not getting data from the hospitals or the health facilities. But like I said, the error rate is easily close to about 30 to 40%, and that's very high. So, you should be careful when using AMD or AMI. You can spend more time and effort in having the data collected from the hospitals and health facilities rather than using the issuer distribution data, since I know it's easy because you have that data already. But this easy technique will lead you to disastrous results, and we have seen that. Now, scenario two. In family planning, contraceptives are very popular. Initially, they used to be oral contraceptives. Um, okay, Okafor is saying her network went off while I was doing AMC calculation. Okafor, I have come to scenario two. So I will request you to watch the recording. But very quickly, what we did with AMC was we divided the total number of products for that 2 years by the period, which was 24 months. When we divided it, we calculated the AMC. So if you see your sheet, which you have received, you will see that total quantity is divided by the period. You got the AMC. We adjusted the AMC with the population increase as an assumption, and then we multiplied that adjusted AMC with 12 months to figure out the forecast for the next 12 months. Okay, so that's the AMC calculation. If you look at the Excel sheet, which you already have, you will find that calculations already done for you. Okay. Okay, coming back to family planning. So we used to have, okay, Shailat is raising her hand. Shailat, do you have any questions, comments? Shailat, you are muted. You need to unmute yourself before you speak. Yeah.
All right, thank you. Maybe for a clarification, in the scenario that we have conditions like malaria, those which are seasonal, if we use 12 months average monthly consumption, I don't know, would it be appropriate for such conditions? Because normally it's a 2-3 months thing that can come and go. So during that month, you have to prepare for your medicines. If you put it for 12 months, you have maybe one over four, 1/4 of the required medicines for that period. So you'll be roaming around every time. I'm not sure. Maybe for contraceptive, it will suit well because it's something that is continuous and that can be monitored. Maybe you can assist me there.
Yeah. That's an excellent question, by the way, Shailet, that you have asked, that can we use AMC calculations for doing forecasting of products like malaria, where we only need it for 3-4 months in a year. Now, AMC means average monthly consumption. The reason we do the average is to make the calculations easier. In the cases where we only use the product a few months in a year, rather than taking the average, we can take the actual consumption. So rather than taking average, we take the entire consumption of that 3 months and we replicate it for the next year with some more assumptions, that if we know if malaria cases are going to increase, if they're going to decrease, if we are taking some precautions. So based on those assumptions, we can adjust that consumption. So rather than taking an average, you use the entire quantity that has been used as a data set. Okay. However, a better forecasting technique for malaria is using surveillance or morbidity data, which is scenario number 3. So if time permits, then I will definitely go on to scenario number 3. We have about an hour left. So let me quickly do scenario 2, and then Shailesh, the question you have asked will also be answered in scenario number 3. So in this scenario, in the same district, there is a product named medroxyprogesterone injection acetate 150 milligram. It's an injection. It needs to be substituted with oral contraceptives. So because it has shown much more effectiveness, and it needs to be taken very few times, and it's very easy to administer as well. So there is more patient compliance. It's more effective, and in terms of cost as well, it is lower. So this injection comes in a pack size of 24 pre-filled syringes. In one pack, there are 24 injections. It's used for contraception. One injection is needed every 3 months, about 12 to 13 weeks. It is under the program of family planning, and the Ministry of Health has advised to the team that at least 50 to 60% of women who were on oral contraceptives must be transitioned to this injection. So this is the target of the program, that at least 60% of women must be transitioned to the injection who are today on oral contraceptives. It is jointly funded by Ministry of Health and UNFPA, and the forecast period is of 12 months. Now we need to do the forecasting using services data. Now, can anyone tell me why we are not using consumption data? Can anyone tell me why we are not using consumption data for this? In the chat, or you can also speak. Anyone? It's a very simple answer, actually. No one? So, is per patient. Yes, it's per patient. So you can, dosage is the same. So it is saying. So it is saying all patients. Okay. Seth, I'm not sure what exactly did you mean, but the answer is very simple, that the reason why we are not using consumption data. Yes, I mean, in terms of services data is very easy, that 1 vial per patient, or we will see how many vials is needed in 1 year. But the actual reason, another reason that we're not using consumption data is because there is no consumption data available for this product. This is a new product. We are using it for the first time. As you see, product substitution. So in District X, all women are on oral contraceptives. And we cannot compare the consumption of oral contraceptives with this one, because the dosage form is different, quantities are different. So we cannot use the consumption data of oral contraceptives, which are generally tablets, to do forecasting for an injectable product, which is also not needed in the same frequency. So hence, by using services data, where it is much easier, or also when it is a new program or a new product. However, before doing that, you must know one more thing, something called a CYP factor, couple year of protection. How many of you have heard of it? You can raise your hand, but let me quickly tell you what it is. Couple years of protection is a measure that estimates the protection from pregnancy provided by contraceptive methods during a 1 year period. So when it says couple year of protection, it doesn't mean 2 years of protection. It means for a couple, for a husband and wife, because the contraceptives can be male contraceptives, it can be female contraceptives. So how are CYPs calculated? There are different methods of contraception, and depending on how long they can be used for, the wastage, how effective they are to prevent pregnancy, that's how the CYP factors is calculated. So for example, if it is an oral contraceptive, the CYP factor is 15, which means for 1 year, in 1 year, to prevent pregnancy, a woman needs to have 15 pill cycles. Okay, so that's why the CYP factor is 15. The CYP factor for condoms is 120. The logic behind is that there are 120 condoms needed to provide one CYP, to provide 1 year of protection. So if this is the case, can you tell me what will be the CYP factor for medroxyprogesterone acetate, the injection that we're talking about? What would be the CYP factor going by this method calculation? Yeah, exactly. Seth, you're absolutely right. The CYP factor for medroxyprogesterone acetate is 4, because as you see here, one injection is needed every 3 months. So in 1 year, we would need 4 injections per couple, right? So that's the way using 4 injections, a pregnancy can be prevented in a couple. So that the CYP factor becomes 4. Okay. So let's now go back to the Excel sheet. Priyanka, if you stop your screen share, and then I'll do the screen share from my side. Please do let me know when the Excel is visible. Is my Excel visible to everyone?
Yes.
Okay. Okay, excellent. So this is scenario number 2 for medroxyprogesterone injection. Key thing to note here is CYP factor, which is 4. Second, there is a target that at least 60% of women who are on oral contraceptives must be transitioned to this new injectable. Okay. We also have a bit more of data that the number of women between the age of 15 to 49 is 60,000 out of 200,000 population of District X. So not everyone are women and in the age of 15 to 49, but only 60,000. The data that we have is of 1 year, January 2017 to December 2017. The data is about the number of women, unique number of women. Women may go again and again, but this is unique number of women who attended clinics in the different sub-districts of District X to receive oral contraceptives. Okay, so different numbers in different months. This is services data. This is exactly what we were talking about. How many patients or consumers who visited the facility. So if you look at the calculations here, the first one is the total number of women who visited the facility for oral contraceptives. So we use the sum function here. We take the sum of all these, the 12 months of data. We do the sum here. Then we figure out what is our program target. Our target is 60% of existing women. So existing women is 25,116 based on the services data of the past 12 months. 60% of this. So 60% of this is 15,070. Okay, so 60% of this data is 15,070. There is one more assumption that we have taken, that it says that we have to do some advocacy in the district. Okay, we have to do advocacy about this product, that this product is very effective, it's very cheap, it's easy to administer, you only need 4 and this and that. So the assumption is that when we do the advocacy in the district, they take an assumption that maybe some more women, they get interested to use this product. Now this 10% are new users, they're not out of the existing pool who were already on oral contraceptives. So this 10% is out of the overall pool, which is 60,000, which you saw here. Okay, new users. So we did the 10% not out of 25,000, but we calculate 10% of 60,000 because they are new users. And this is an assumption. Okay. So for the first year, when we're starting this program, what is the total number of women where we will dispense this product? So we sum or we add this number 15,000 with the 6,000. So we come at 21,070. This is the total number of women who we think, based on assumptions and program target and based on the services data of the previous year, we believe that these many women will need this injectable contraceptive. Now the key question is, what is the CYP? So how many injections will be needed per woman? That is 4. So if we need 4 injections per woman, so in 1 year, we will need how many? 21,000 multiplied by 4, which is 84,280 injections. Now, if we have to convert this into packs, we can divide this number by the number of packs, which is 24. So if we divide this number, 84,280 by 24, we get 3,512 packs of medroxyprogesterone injections that is required for the first year of operations of this product. Okay, if you change the assumptions here, if you say the program target is 100%, then the numbers will change. If you say that based on the advocacy, there will be more users or less users, then again the assumptions will change and the numbers will change. What I want to ask you is, what other assumptions can we use in this scenario to create our forecasts? What other assumptions that we can take in this entire scenario to create our forecast for the next year? If you have something in mind, please, if you can write it on the chat, or you can also speak. What kind of other assumptions that you think we can take? Buffer stock. So again, Seth, if you remember in the beginning when I said we are not doing quantification at this point, we're only doing forecasting first of all. So we're not talking about any stock on hand, buffer stock, safety stock, wastage, etc., etc. Also, in this example, there is no buffer stock. This is a new program. The existing stocks are of oral contraceptives, which will be phased out eventually, or may not be entirely phased out, because some women may prefer only oral contraceptive. They may not want to go to injectable because, a lot of people, they fear injections as well. So, but today in District X, there are no buffer stocks of medroxyprogesterone. If you look historically, also, if we want to add a buffer, as some can break, that is the next step after forecasting. When we do supply planning, when we add wastages, when we add stock on hand or whatever that is the next stage. But I'm talking about assumptions for forecasting. Like we have taken these two assumptions, that program target is 60% and there will be 10% new users based on advocacy. So can we take any other assumption like this? Okay. Let me give you one more assumption which we can take. So, like I said, this contraceptive is used by the women who are in the age bracket of 15 to 49. We know that the growth rate is 3.2%. We know that the next year, this number, which is 60,000 today, this may also change because there may be more women who come in the age of 15, right? So that may be another assumption that you can take, that next year, maybe 3% more women will be eligible to receive contraceptives, for example. So that's another assumption that you can take. So then the number of products will increase. Okay. Or you can also say that, some women will stop taking contraceptives, because they will cross the age of 49 or 50. So you can reduce that as well. So that is another assumption. There can be more assumptions as well. I mean, in different scenarios, there can be other assumptions. There can be some cultural assumptions as well. There can be some assumption related to, like I said, some people have a fear of injections. So that can be another assumption depending on the area and history and historical backgrounds as well. So different assumptions can be taken, but the key data which was used here was services data. So this was the main data set which was used and converted into product quantities using something called a CYP factor. So if we did not have the CYP factor, then we would be stuck here, that we need the product for 21,000 women. Now we don't know how much product. So to do that, we need the CYP factor. Okay, so this is how we convert services data into product quantities. So in this particular case, we use the CYP factor. Okay. Let me quickly go to forecast 3 directly here in the Excel. I think we have some time. I will quickly explain this. I'm only going to take 5 minutes here. You can read about it later. This one is for malaria using surveillance or morbidity data. Okay, and using standard treatment guidelines. So again, here we don't have any consumption data. Okay, even if we have, it's very difficult. Like Shalit was saying, it's only there for 3-4 months. It's not always very accurate. So instead of using consumption data, we use morbidity data. Now for malaria, the product that we have is artemether-lumefantrine. This has a very specific way of administration. So it depends on age and weight of the recipient. So for children, 0 to 3 years of age, 3 to 8, 8 to 12, it is a 3-day regimen with, on each day, 0 to 3 years of children, they need 2 tablets, 3 to 8 years need 4 tablets, and 8 to 12 years of age need 6 tablets every day for 3 days. And then adults, or let's say 12 years and above, they need 8 tablets per day. So these come in different packs as well based on this regimen. So for infants 0 to 3 years of age, it comes in a pack of 30 into 6, that is 180 tablets in a pack. And then in a pack, there are small strips of 6 tablets, so that for each patient, they can give 6 tablets. So in a pack, there are total 180 tablet or for 30 patients, but in the age group of 0 to 3. Similarly, for 12 years and above, again 30 patients, but for each patient 24 tablets. So in total, the pack has 720 tablets. So this is what the complication is in this particular scenario, because the treatment regimen varies by age. Now, the surveillance data says that in an annual basis, 18% of people in District X, they contract malaria. For children, it's about 7%. So 7% of children across all age group, 0 to 12, they contract malaria, and 18% of adults or 12 years and above, they contract malaria. So what we are going to do using this data of surveillance and this data on treatment regimen. We only have these two sets of data, treatment regimen and surveillance. These are the two main sets of data we have. We don't have any consumption data. We don't have any services data. So how we are going to do it? First, we will determine the number of prospective patients, So we will determine how many adults are there, okay, in total in district X. Okay, we know the number of children here. No, it is given. The data set is given here that in district X, 0 to 3 years of age, 18,000, 3 to 8 years of age, 25,000, and 8 to 12 years of age, 6,700. So we write them down and then we try to understand the incidence for each category. For adults 12 years and above, 11% multiplied by this number, 150,000 adults which are there in district X. Same in children 0 to 3 years, 7% multiplied by 18,000, 7% multiplied by 25,000, and then 7% multiplied by 6,700. So let me delete this one. So we have these children across different age groups, who have a chance of contracting malaria. And then for adults, these many adults have a chance of contracting malaria. Now, we also know that every year there's a 3.2% growth rate. So we know that 3.2% additional newborn children will be there, and the incidence rate is 7%. So 200,000 multiplied by 3.2% gives us the growth next year. And then if we multiply it by 7%, we come to about 448 patients in the bracket of 0 to 3 years who can be new additional patients who can be there for the next year. So using this data, that prospective number of patients can be this. So just like the services data where we knew that total number of women are 21,000, then we converted it into product quantities using CYP factor. Here, the number of prospective patients, to convert it into product quantities, we use the treatment regimen. So we know for adults, these many number of adults will require malaria or will contract malaria. They need 24 tablets of artemether lumefantrine. So if we multiply this number by 24, we get 396,792 tablets required for adults. And if we divide it by the pack size, which is 720, we will get the answer that we need 552 packs in 1 year for adults. Similarly, we do it for the other age categories. For 0 to 3, we multiply by 6, 3 to 8 multiply by 12, and 8 to 12 multiply by 18, and then divided by the number of tablets in a pack. So without any consumption data, without any services data, we calculated the amount of products needed to treat malaria. So Shailit, I go back to your question. When you don't have reliable consumption data, you find out the surveillance data in your area, in your district, in your state, in your country, and use that data along with the treatment regimen, and specifically in cases of malaria and any other seasonal, seasonal viruses or seasonal diseases. This is a very helpful way of, very accurate way rather of doing forecasting. This may sound a bit complicated at the moment, looking at a high level, but if you go through the sheet step by step from top to bottom, it is very logical. We first understand the data, the standard treatment guideline. Then we identify the number of prospective patients using surveillance data. And then we convert the number of patients into products by multiplying them by the number of tablets required per patient. Okay, so it's very simple. if you look at it like that. Okay, so this is the surveillance on morbidity data. Now, finally, I will go back to the slides at the very end. So finally, scenario 4 is using something called a trend function of Microsoft Excel. Trend function. You may have heard of it, you may not have heard of it, but as you know, in Excel, there are many formulas and functions that you can use. So we have the same scenario which we used in scenario 1 of ciprofloxacin, same data set, 24 months. But this time, instead of using average monthly consumption, we will use the trend function. Okay. Now, before I tell you how, what are the calculations of a trend function, let me explain it to you the concept. So if I plot this data, month by month consumption of ciprofloxacin on a graph, it will look like this. It will look like this, the orange line. The orange line represents the month by month consumption of ciprofloxacin for 24 months. So I can ask you, what is the trend here? Where is this line going? So the gray line here, it is showing us the trend. You see, it is cutting somewhere in between this crests and troughs, which you see on your screen. And then this line can be extrapolated as well for the next 12 months. So using this extrapolation, we can calculate our forecast. So instead of AMC, we can use this extrapolation method to calculate our forecast using a trend analysis. This is called trend analysis. This is a very popular way of preparing forecasts in various sectors, and not just health, but in various sectors. It's called trend analysis. So first, we identify the trend in the existing data, which is the first 24 months. And then we extrapolate that trend for the next period, whatever that is, in this case, 12 months. Now, how do we do that? We do that using this trend function. So this one is same. We have number of tablets. We divide it by 100, we get number of packs. The trend function uses something called known x's and known y's. Okay. So what is the x-axis and y-axis in this graph? X-axis is the time period. Y-axis is the consumption. Okay. So the formula is, if you see here, let me also make it bigger. Let me make it so here. So the formula is also coming at the bottom. So it says trend known y. Known y is the consumption. So known y is here, D. Our D column is consumption. So we select all the known y, which is the first 24 months. Then known x. Known x is the period. So this is the period 1, 2, 3, 4 until 20 up to 24. So when I complete this formula, trend, known y, and then known x. Okay. And what I do is I also select the 24 cells here, and I press Control Shift Enter. Okay, so this is a slightly different way of using this formula on Excel, that I do it for all the cells at once. Okay, so I make this formula and I press Control Shift Enter. I think it's written here. No. Okay, no, it's not written here, but we press Control Shift Enter. So Excel, what it will do is it will show me the entire trend analysis for the 24 months until here. Okay. So first step is we find the existing trend of the data. This is here. Now the second part of the puzzle is we need to find the, using that same trend, we extrapolate the trend in the next 12 months. So what we do now here, the formula will slightly change. What will happen is, known Ys we already had first 24 months, sorry, for consumption in 24 months. Then we have known X, which is first 24 months. And then the new X, what do we want to calculate for what period? This next 12 months, 25 to 36, next 12 months. So then once we put this and press Control Shift Enter, it will extrapolate all the data here. So this is the extrapolation which I showed you on the graph. This area, this area. So this area is now represented in numbers here using the trend function. Okay. So if I do this with you, let's say if I do this with you, so I've selected everything and I press is equal to trend known Y. So for me, the known Y is here. Then known X's. Known X's is here. Then new X. New X is here. And then I put Control Shift Enter. When I do Control Shift Enter, you see all these fields are populated once again. So the what it did is it extrapolated this trend. If you see the trend here, it starts at 86, 87, 88, 89, 90, 91, 92, 93, 94, 95. So to understand how much product is needed for the 12 months, then we take a sum of this 24 months, which is presented here. Sum of these 12 months, 1122. So this is another way of forecasting using the trend function of Excel. In your assignments for this week, you will have a similar sheet. Some data will be given. You will be asked to find out the trend, and using that trend function, the exercise is to find out the overall forecast using the trend function, okay, which will be there in the quizzes on the platform. So you can use the same formula which I showed you, which is here. You have all these sheets. You can use the same formula in your sheets and find out the trend and find out the forecast. Okay, I will quickly stop here for 5 minutes, answer any queries that you have. It may sound a bit complicated at this point, but if you know how to use Excel, it is very simple. I've also given you all the explanation here. Known Y's, known X's, new X's is forecast period. So all this is mentioned here, extrapolation, everything is mentioned here. You just need to, read it a few times and you will understand. So if you have any queries at this point, please ask them. In the meantime, Priyanka, can you share the PowerPoint? Any questions, any clarifications about the malaria case, about the trend analysis, or even the family planning medroxyprogesterone injection case? So this brings us to a quick poll. Priyanka, can you launch the poll? Now, what I want to ask you is what data set is usually used in your country or organization to develop forecasts? So while you are reflecting on all the scenarios that I've run through with you, if you can also quickly do this poll, just so that we understand what kind of data is being used more often than not, because you can only choose one option here. It will also give us some idea of how you are doing forecasting in your country or organization. But in case if you have any questions, any clarifications, please feel free to ask them. Okay, so majority of you are saying combination of consumption and services, and then in some places it is just consumption data. So which is very common. Like I said before, these are the two data sets which are easy to collect, and in most places these data sets are being used. A key thing which we talk about when looking at quality of forecasts, we talk about triangulation of data. We say that also try to collect one more set of data in addition to consumption and services. It can be surveillance data. It can be basic demographic data like the population and everything, just to validate the forecast that you have prepared using consumption and services data. Okay. Now, we understand that services data, demographic data, surveillance data, they are always challenging, and creating forecasts using these data sets is always challenging. And the key reason is they are difficult to collect. So that's why in so many places we see forecasts are being developed using consumption data because it's slightly easier to collect and within the purview of the supply chain organization as well. However, these data sets, they are available with the Ministry of Health, with the health facilities directly, and it's very difficult sometimes to collect these data sets. However, if you can collect this data, your forecast will be better, they will be more accurate. But if you can't, then your accuracy will be lower, okay, more often than not. Very quickly, if again, before the final step of forecast errors, forecast accuracy, if you have any questions about the forecasting techniques, please ask them on chat or you can also speak. I'll just pause for 10 seconds to see if anyone has any questions, and then I will go to the last step of this session. Yes, Philip, please, you can speak.
Okay, thank you. Sorry to continue taking you back on the issues of malaria, maybe even COVID. It's a pandemic which comes and goes.
Shailit, we lost you. You said something about malaria.
I think those things they are not easy. Yeah. They are not easy to handle when it comes to reality using the consumption, even the consumption rate. I'm talking from experience, checking
Yes.
into my country for last year and this year. Previous year, there was a lot of malaria conditions that maybe, for example, at my hospital, which I used to work, we're using 1,000 vials per month during the seasonal months. So if I take that one and use it for the next year, the coming year, malaria was overtaken by COVID, maybe because of face mask. I don't know what really happened, and it just falls down. Yet we were prepared for malaria. That also led to high rate of expired drugs, of which we are also being afraid of. So I think it's a bit tricky. We need to play our guitars very. I don't know how we can do it. That one, even myself, I'm not so certain on how I can manage such conditions. Like COVID, normally we're saying when it's cold, it's coming up, and when it's not cold, it goes. Now we are in winter, COVID has reduced. Well, at least we had prepared that a lot of patients might be affected.
Mhm. Shailet, you have asked some very pertinent questions, and also, um, which are reality today. See, all these techniques that we're talking about, these were based on established disease patterns. COVID is something that we have not been able to understand so far. So COVID is very unpredictable. We don't know the real pattern for COVID, you know. So if we take COVID into account, I would recommend creating forecasts using 2 or 3 different techniques, and then adding something on top, because we are in the last 2 years, we are not seeing much of expiries or products sitting on the shelves. Rather, in majority of places, we have seen stockouts of masks, stockouts of gloves, stockouts of vaccines, stockouts of other products which people are taking to manage symptoms of COVID. So my recommendation would be use consumption data, use services data, use demographic data, whatever data that you can find, use them individually to create your forecasts, then compare them. And then once you finalize one forecasted quantity, then add something more on top, just to be on the safer side, because this is something that doesn't seem to go away, even with all kinds of vaccines and hygiene and everything. So it's advisable to make sure that you're not just using one set of data, and also add something on top, just so that you are not stocked out eventually. So in terms of COVID, that would be my recommendation. Although I'm not an expert in COVID by any means. People are struggling. I can tell you, even here in India and everywhere else, people are struggling with COVID. Even on the screen, which I have, the example that I've given is that no one knew in 2019 that they would need probably 1,000 times the amount of medical gloves and masks that they were using in the previous year. But because of COVID, the consumption of masks and gloves have risen like anything, and we still don't know. Since, and you see, for masks and gloves, your shelf lives are still slightly higher, so you can still take a risk. You should not have higher forecasted amounts for those products where the shelf life is less. But for products which have higher shelf lives, you can have slightly more in hand. You can order a bit more if you have the budget. I mean, of course, budget is always a constraint eventually. But depending on your budget, I would recommend triangulating your forecast using different sets of data and not using just one set of data, because by the time you're doing the forecast, maybe that data becomes obsolete. So it's advisable to take more than one set of data. Now, in terms of other disease like malaria, which is seasonal, and also in a way where things can change from one season to the other, like I said, don't use consumption data only. Use consumption data as a whole. Don't use average of that consumption data. So for 4 months, whatever commodities for malaria that you used, maybe you can just replicate those for the next year. That is your one set of data. Then do the forecasting using another method like I just showed you, using surveillance data. Then take some assumptions. For example, take weather patterns into consideration. Maybe in 1 year there will be less rains. You can, have that data from the weather department. If it rains less, then there will be less mosquitoes. There will be less malaria. If it rains more, there will be more malaria. This possibility of more malaria. Then maybe you can also take into account that, okay, the department is looking at spraying of insecticides Department is looking at distribution of LLINs in the country or in the state or in the county. Department is looking at fumigation. And if all these things happen before the season starts, there will be less malaria, right? So if you can find all these data sets well in advance, then you can adjust your forecasts as well. I know it is very painful because in majority of places, these decisions are taken at the very end. And I know even where I live, a couple of years back, they were distributing LLINs after the malaria season got over. So this is a reality. I mean, we live in a world which is bizarre. So I mean, there are no methods or techniques for that. But in an ideal scenario, you need to find out those assumptions. You need to find out what is happening, which will affect the disease progression, and then prepare your forecasts accordingly. Okay, so that is specifically for diseases like malaria, dengue, or any other disease which is linked with seasons. Linked with weather. So all those diseases you can take these kind of assumptions into account. Now, finally, forecasts are never correct. Forecasts are not supposed to be correct. They're always wrong. Let me tell you very frankly, they're always wrong. So it will be a 1 in a billion chance to have a 100% accuracy of a forecast, and I don't know anyone who has ever achieved that. Even if you have 90% accuracy, that would be also a fluke, I would say. Uh, in majority of cases, forecasts are probably at the very least 60% accurate at the very least. I mean, one of our instructors in the French class, he used to work in Canada, British Columbia. It's a developed country, better systems, better data, and everything. In one of their vaccination programs, they did a forecast, and eventually, when they compared the data, their forecast was only 4% accurate. They had 96% error rate. So you can imagine, even with very good systems, data collection, and everything, their forecast was completely wrong. It was nowhere near being correct. So it happens. It happens everywhere. Forecasts are never right. But there is a way to ensure the accuracy of forecasts over a period of time. Okay. So for a new program, mistakes are bound to happen. But as your program goes along, 2 years, 3 years, 4 years, 5 years, you can have better forecast accuracy. How do you do that? You do that by understanding the error rates in your forecasts and using those error rates while doing the forecast for the next period. Now, to calculate error rates, there are three methods. First is called mean absolute deviation, which means sum of all mistakes, sum of simple mistakes. You can read the definition here. It just means the mean of all the deviation between the forecast and the actual. The second is mean squared error, MSE. It means just squaring the mean absolute deviation rate. So if you take the square of the deviation between forecast and actual, that becomes the mean squared error. And then finally, we have the mean average percentage deviation. Simply means to depict the error in percentage, because sometimes some people may not understand your absolute error rates. So for example, if you see what's written on the screen, for example, telling your manager we were off by less than 4% is more meaningful than saying we were off by 3,000 tablets, because the manager may not know the overall volume that is being on order. But 4%, people can understand that, okay, 4% is less or 4% is more, or whatever that is. So to show it in percentage is slightly more easier to understand. Okay. So let me very quickly take you back to the Excel. Priyanka, if you can stop the screen share from your side, and then I'll quickly take you to the Excel. Again, you all have this. What we're doing here is comparing two forecasts with the actual consumption. The product is again same, ciprofloxacin. The first forecast is coming from the average monthly consumption, which we did in scenario 1. The second forecast is coming from the trend analysis, which we did in scenario 4. The actual consumption data is hypothetical. Okay, it's also written here. This data is fictional. It's hypothetical. Okay. Now we have these 3 methods which I showed you: mean absolute deviation, mean squared error, mean absolute percentage error. So we'll identify all these 3 for the AMC forecast and the trend analysis forecast. To calculate mean absolute deviation, first of all, we calculate the deviation between the actual consumption and the forecast. So what is the deviation between these? So if we do the deviation here, so F12, which is actual, minus B12, which is the forecast using AMC. The reason why I've added this ABS formula here, which means absolute, so that it does not show the error in minus negative format. So it always show it in the positive form. Okay. So we use this formula: absolute, F12 minus B12. F is actual consumption, B is forecast. So we do this for all these months, and then we take the average. So average of all this, all the months, 12 months, becomes mean absolute deviation, which is 5.98. Similarly, to do mean squared error, first of all, we take the square of each of these absolute deviations here. So square is in Excel is this small cap like arrow, a cap like symbol, and then in like square is 2. Okay, so I12, I is absolute deviation, and this is squaring of this. So we do it for all the months, and then we take the mean. It becomes mean squared error. To calculate the percent, we divide the absolute deviation by the actual consumption. Okay. If we divide the deviation by actual consumption, we find the error in percentage. We do it for all the months, and then we take the mean. It becomes mean average percentage error. In Ethiopia, in their, if Janet is here, in your monitoring and evaluation framework, it is written that you are supposed to undertake forecast accuracy using MAPE. So the forecast team, I think you are in the quantification department, you should be doing this, or probably are doing it already. You are estimating the forecast error on an annual basis using MAPE. It is written in your monitoring and evaluation framework as well. We do the same analysis for the trend, forecast with trend. Now, instead of using the forecast of AMC, we use the forecast of trend, and we calculate absolute deviation, squared error, and percentage error. And then we take the mean of everything. In this hypothetical scenario, what it says that the forecast developed using trend is about 0.8% correct than the forecast developed using the AMC. This is a hypothetical situation. Okay, maybe the forecast in some cases forecast developed with AMC can also be correct, or rather more accurate than done with trend. It really depends on how it eventually happens. So there is no one can say that if you use trend, it will give you much better forecasts. But in the long run, if you are using trend analysis, it will give you better results eventually. But you have to do these exercises again and again. You create a forecast, then you compare it with actual consumption. Now you know that you have 5% error. So when you do it the next time, you add or delete that 5%, because you know the error that you had in the previous forecasting period. So you adjust. It becomes an assumption for the next forecasting period that we had an error rate of 5% or 10% or 15%. So we are adding more. Okay. So this is how you understand errors and you accommodate this error in the forecasts. Okay. So all this you have. If you go through these one by one, you will understand very easily all the formulas and everything are written here. If you don't understand anything, please do not hesitate to drop us an email. We will help you understand everything. Let me see, there are some comments. Sure, Kenneth is saying yes, you're right, we're using it absolutely. Yes, it's being used in Ethiopia. So in this session, we understood different forecasting techniques: average monthly consumption, services data, surveillance data, demographic data, and then using the same types of data, but using something called a trend function or trend analysis to calculate forecasts. And then finally, we looked at how to calculate error rates and then how to reconcile your forecasts using those error rates. So if you have any questions, any clarifications, please ask them. I know it can be slightly heavy, but these are the basics of forecasting that you must know. See, we all have the softwares today to do the forecasting, but the softwares will not tell you how the forecasting is happening. So you are always kind of in the dark. Okay, how did it happen? So it is important for you to know the basics so that if you're using any software, it doesn't matter. You know the basics, because if you know the basics, you know what are the data to collect. In forecasting, the most important thing is the data that you collect. Everything else is secondary. If you don't have the right data, the forecast will always be wrong. They're anyways wrong, but it will be even disastrous, I would say, if you have the wrong data. So understanding these basics will tell you how and what kind of data you're going to collect, which will help you create better forecasts. So this is the end of the session. Any questions, any clarifications are welcome. And then I'll request Priyanka to launch the feedback for today's session. We're still online, so if you can, if you have any questions, anything, please, you can ask them. Still online for a few more minutes. Okay, excellent. Thank you for the very good rating. I hope this was something interesting and new for you. If anything you have not understood, again, please don't hesitate to email us, write on the Hive or everything. And wherever that you reach us, either on WhatsApp or Hive or email, we will respond to you as soon as possible.